Today we're going to look at algebraic properties of equality and see how they apply to proofs. So some of the algebraic properties of equality are the addition property, subtraction property, multiplication property, division property, reflexive, symmetric, transitive, and substitution. When you're working with equations, a lot of times you're going to be using those first four. And the addition property just states that if A equals B, then A plus B equals B plus C. And basically, when you use that as a proof, all you're doing is, it's like if you were adding something to both sides of the equation. So you justify your answer by saying, oh, I used the addition property because I added something to both sides of the equation, the same amount. Subtraction property, same thing. If you subtract the same amount from both sides, then you're using the subtraction property. Same thing with the multiplication property and the division property. The reflexive property just means that if A equals 5, then A is going to equal 5 throughout your proof. The symmetric property is if A equals B, then B equals A. So if you have two different variables and they equal the same thing, then you can flip them around. Transitive property, if A equals B and B equals C, then A equals C. So let's say A equaled x plus 4 and B equals y plus 3. And then you've said, oh, well, C equals x plus 7 minus 42 or something like that. You could plug that C value in for A or B because you're saying in this transitive property that B equals C, and therefore A must equal C too. Substitution property, if A equals B, then A can be substituted for B in any equation or expression. That just means that if you have a variable and it equals like 5, you can plug that in anytime you see an x. Or let's say A equals x plus 4 and B equals y plus 7. You can plug those in for the A and the B wherever you want. So let's look at a proof first of all. So this is the first time we're going to jump into a proof. And we're just going to do an algebraic proof. We're not going to use geometry right now. So algebraic proof. And before, you know how to solve equations. That's very easy for you. But now you need to justify what you're doing each time. So I'm given an equation, and the equation is 3 parentheses x plus 8, parentheses closed, equals 24 minus 8. And basically you could say that 3 times the sum of x plus 8 equals the difference of 24 minus 8. And whenever you start a proof and you have a given equation, you just write given. Because there's nothing that you got that from, like it didn't come from anywhere else other than it was given to you. Okay, so the second thing that we're going to be doing is starting to solve this. So the first thing I might do is simplify this side. And when I simplify it, I'm going to get 16. And all you're going to put for your justification is simplify. You didn't add anything to both sides, you just simplified the side. Now I'll do 3x plus 24 equals 16. And all I did there was do the distributive property, so we just put distributive. That's how I got to this point. Next step I might do is subtract 24 from both sides. So I'm going to have 3x equals negative 8. And the way I got to this point here was using the subtraction property of equality. So if you look, I subtracted 24 from both sides. So that's the subtraction property of equality. And the next thing I'm going to do is divide out my 3. And so my answer is x equals negative 8/3. And my justification for doing that was the division property of equality. You're really only going to be dealing with those the top 4 properties when you're doing equations. So tomorrow you're going to be doing some algebraic proofs that look exactly like this. So you want to take down your properties and be ready to do that. Okay, thank you. Bye.